Now here we have these are the three, that is we are comparing current and voltages. They are parallel, one is behind, one is ahead. Okay, that's it. Now when we are drawing a vector diagram, here if you see the vector diagram, in the vector diagram we have VC. This is VC, voltage of the capacitor. Voltage, see, this is important. First draw the voltage of the resistor. Sir, you may ask me, sir, only we have to draw in this way. Can't we draw in the other way? Yeah, we can draw still. Suppose you rotate it, bring this along x-axis. This will come here and this will come here. Got it? Once again, if you bring this along x-axis, this will go along y-axis, this will go along negative y-axis. But the problem is why we don't draw like that. There is a reason. Because if you draw along the axis, you can't know where exactly is the voltage. That is the reason. हम लोग अगर draw करेंगे इस तरह से, suppose if you are drawing in this way, like voltage is this voltage of resistor and voltage of inductor and capacitor, इस तरह से अगर draw करेंगे तो समझ में नहीं आएगा. So that is the reason we drew in that way. Got it? And with the vector length also we need to calculate. For that reason we are drawing in that way. We are not drawing in this way. Is that clear? All of you? Is it clear, all of you? Okay.
Yes, sir.
So next one. So when we are now, let me discuss this figure then I will go ahead. Now here, this is, see here, if you see carefully, VR is what? We both are parallel, right? Current and voltage across the resistor, both are parallel. Now, if you are comparing the current with current, who is leading in capacitor? Current is leading, right? In capacitor, current is leading. So current is leading here with respect to capacitor. But if you go to inductor, who is lagging? Current is lagging. Current is lagging voltage. Is that clear? Is it clear, this diagram, all of you? Okay, and what is the angle?
Yes, sir.
Omega t plus phi. This is the angle. Okay. Now this is a vector diagram. When the two vectors in the same direction, we add it or subtract it. When the two vectors are in the same direction, do we add it or do we subtract it? Add it. Is it not? When the two vectors are in the same direction, we add it. But if they are in opposite direction, we subtract it. So these two are in opposite direction. We subtract it. Then we got this. Because the length of this vector is more than the length of this vector. So we got this. Understood now? Now what we did, go back to again grade 11. Grade 11, parallelogram law of vector addition. It is in motion in a plane chapter. It is in motion in a plane chapter. So in parallelogram law of vector addition, complete the parallelogram first. There are two vectors now. Complete the parallelogram. Then you get the diagonal of the parallelogram will give the resultant direction and magnitude of the resultant force. Is that clear? If there are two vectors, complete the parallelogram and what I have to say, the diagonal of the parallelogram will say the direction and magnitude of the resultant vector. Is that clear? Is it clear, all of you?
Yes, sir.
So I think hope you have already drawn this one. So I wrote VL VC plus VL. Is it correct or is it wrong? Correct only, right? Should I write VC minus VL? For magnitude, I wrote minus. But for vector type, I wrote plus. Why? You didn't notice this? For say, VCM minus VLM. VC plus VL. M माने magnitude. Magnitude, if you are taking the magnitude, इसको subtract करना है. If this is 10, this is 6, subtract it. 4 बन जाएगा. That is this value. ठीक है? Is it clear? But when you come to the vector thing, we are still adding the vectors. Subtraction is nothing but still adding the vectors only, but in the opposite direction. Got it? Is that clear?
Yes, sir.
Okay. Okay. So I think hope you have already written this thing. Did you all write this one? Just check if you have written or not. Then I will go with the next concept. I will have to complete this one now. Are you done, all of you?
Yes, sir. Yeah.
Okay then. Okay, going ahead now. Now here we are writing here VRM magnitude of the resistance is equal to what? IM into R. Now VCM is equal to what? IM into XC. VLM is equal to what? IM into XL. Okay. This is the voltages. Now, what is V? V is equal to what? VR plus VC plus VL. Okay. Now, this is the magnitude. And if you are comparing the vectors, V is equal to VC plus VR plus VC plus VL. Okay. Now, so here VC and VL both are in opposite direction. So if you are writing the vector in the vector notation, it will be like VC plus VL when we are taking vector. Okay, vector, this is vector addition. This is vector addition. And VCM minus VLM. Yeah, VCM minus VLM. That is the magnitude. This gives the magnitude. Is it clear all of you? No. So what we are doing now, we have a right angled triangle. Okay, VR and VC plus VL. Okay, they are what they are in a same line opposite. So we can use triangle law, right angled. We can use right angled triangle. Okay, we can use right angled triangle. Okay, so we have what? So we can use VM square is equal to what? VRM square plus VCM minus VLM whole square. I'm writing square of this. Like, what is that? Hypotenuse square is equal to what? Opposite square plus opposite side square plus adjacent side square. This is from Pythagoras theorem. Is it not? This is from Pythagoras theorem. I'll write here. This is from Pythagoras theorem. Pythagoras theorem. Okay. So we got this value. So what do we get now? Vm is equal to what? Vm is equal to Im into R. Im into R whole square plus what is VCM? That is Im into XC minus Im into XL. Im into XL whole square. Okay. So now what do we get now here? Vm square is equal to what? Vm square is equal to Im square. When you take it Im outside, it will become Im square into what? R square plus XC minus XL whole square. XC minus XL whole square. This is the value. Now what is that? Im is equal to what? Im is equal to Vm divided by under root of Vm divided by under root of R square plus XC minus XL whole square. XC minus XL whole square. So we will write here Im is equal to what? Vm into Z. Vm divided by Z. Im is equal to Vm divided by Z. What is Z? Z is Z equal to set this value. What is that? R square plus XC minus XL whole square. This is said to be what? Impedance. This is said to be impedance. Impedance is also measured in what? Ohms. Units of this is ohms. Why ohms? Because it's also concept of resistance. But what is the difference between resistance and impedance then? The difference between resistance and impedance is both are measured in ohms, but impedance comes with the frequency component. You cannot say in DC circuit, you cannot say impedance. When your components are connected in DC or applied across DC, it's a battery, you cannot say impedance. Why? It doesn't have a frequency component. A battery है समझो, जो output है ना इसका, charger है, जो भी है. You cannot just take, no, I will say impedance. No, you cannot say. Because impedance comes with the frequency component. DC में frequency component नहीं है. Whereas AC में frequency component है. इसलिए उसको impedance बोलते हैं हम लोग. Is that clear? Is that clear? अभी स्टार है, स्टार बोलेंगे. अगर स्टार in gyration we say गर्दिश में है. ठीक है? Is it not? In Hindi, what we say. The same way. The concept has changed. Okay. Now here we have I is phasor parallel to IR. So here we'll draw the triangle now. Here we'll draw the triangle. Now, in the triangle I'm taking R. This is Z. This is XC minus XL. And this is phi. XC. This is phi. Is that clear now? So what did we get now? So now 1 second, please. One second. Now, so here we have so we have here tan phi is equal to what? Tan phi is equal to Tan phi is equal to what? VCM minus VLM by VCM minus VLM divided by R. Magnitude. Okay, this is the magnitude. Now, is it clear, all of you? So just take the subtraction VCM minus VLM by divided by R. That will give the phase angle. So just we can write, how do we write the phase angle now? Phi is equal to what? In simple words, we can write phi is equal to tan inverse of VC plus VL divided by R. When we are writing magnitude, we write in that way. See, XC minus XL divided by R. Okay, XC minus XL divided by. That is the phase angle. Very, very important formula. This is very, very important formula. XC minus XL divided by R. What is XC? XC is equal to 1 by omega C, and XL is equal to what? Omega L. These are the two values. XC is equal to that value. Okay. So can we substitute here? We can also substitute. See here. How do we get that? I'm just writing here. Tan phi is equal to what? I into Rm minus I into XL, IM into XL divided by IM into R. Voltage across this. This is VR. Okay. That is VR. VRM. Okay. So what will happen? IM into R. XC will become XL. Here XC. So what happens is IM will go away. Okay. IM will go away. One second. One second. Just getting the message from our own. Day after tomorrow I have to go right. So now. So what do we get here? Tan phi is equal to क्या मिलेगा हमको? XC minus XL divided by R. Okay. So यही formula आ गया अभी. Now if you reverse it, you will get phi is equal to tan inverse of XC minus XL. ठीक है? Is that clear? Is it clear, all of you? Yeah.
Yes, sir. Yes, sir.
Take. Please copy this one, please. Let's take our resonance. Okay. What is resonance? Resonance. The phenomena of, it is a tendency to oscillate. It is a tendency.
Is below 70. There is 60.
It is a tendency to oscillate.
Minus.
Tendency to oscillate at a particular frequency. At a particular frequency called natural frequency. Called natural frequency. Okay, so here what is that? We write here IM is equal to VM by C. Okay, so which is equal to what? VM by under root of what? Under root of R square plus XC minus XL whole square. XC minus XL whole square. Okay, so we have what? We know that XC is equal to 1 by omega C and XL is equal to what? Omega L. Okay, XL is equal to omega L. Okay, so here at resonance frequency. At resonance frequency. At resonance frequency, what will happen? At resonance frequency, we write here omega 0. What is that? So XC will become equal to XL. Okay, and Z is equal to what? Under root of R square plus 0, which will become equal to R square. Under root of which will become equal to R. That is resonance frequency. Also, we know that XC is equal to, at that time, XC will be equal to XL. Okay. So 1 by, yes, madam. Omega naught C is equal to omega 0 into L.
ये कीड़ा और ना
उस टाइप की ब्लॉक कर दो।
स्नैप पे ब्लॉक तो इसका वजह
Yeah, 1 second.
ब्लॉक नहीं, रुद्रा अनब्लॉक नहीं, पर अभी मैं उसको पता नहीं।
Now here x 1 by omega c. So what do we get now? क्या आएगा यहाँ पे? Omega square is equal to what? 1 by LC. So omega 0 is equal to 1 by square root of LC. ये फॉर्मूला है उसका. ठीक है? Is it clear all of you? Okay. One second. So omega 0 is equal to 1 by omega c. Okay, so resonant frequency current amplitude is maximum. At resonant frequency, at resonant frequency, current amplitude is maximum. Current amplitude is maximum. At resonance frequency, current amplitude is maximum. Okay, so we can write here Im is equal to what? Vm by R. Okay, we can write here Im is equal to Vm by R. Is it clear?
Yes, sir.
किधर है आप लोग? हाँ.
Yes sir.
हाँ. हो गया थोड़ा. हाँ. हाँ.
Yes, sir. Actually, sir. Our seating is in auditorium.
Auditorium, yes, I told already to HR.
Sir, why, sir? ऐसे मत करो.
Okay, now here if suppose I will draw the phasor diagram. No, ये कोई phasor diagram है. If I am drawing the phasor diagram, this is the voltage. This is the voltage and this is the current. This is very very important, man. This you have to draw whenever you get. I is the current and this is the phase angle. ये phi है और ये omega t.
लिख दिया सर ने।
हाँ?
सर ये अभी लिखा।
हाँ अभी लिखना आप लोग बात कर रहे हैं. हाँ. So see here I is equal to V by Z. Z ये है और उसका प्लस ये important है sir. Very very important. They are asking 1 marker question on this one. Very very important. 1 marker question. And XC is equal XC XL is given. Resonant frequency में both of them will become equal. And then XC is equal to XL. Then we cross multiply. We get this. Okay. So if you are asking me to draw the phasor diagram, it will be like this. It will be like this. So what will happen now? So.
Yeah, we have
Something like this. Okay, you will get phasor diagram. This is what ये V है और ये V है, ये current है, ये I है. Okay, V है, I है. You can write I small I. Voltage and current. Okay, ये दो जो angle है ना omega t. ये जो angle है omega. Okay, this is omega t versus omega t versus phi. That angle is said to be phi. दोनों के जो angle है ना, ये दोनों के बीच में जो angle है ना, ये और ये है phi. Phase difference. Phi, that is phase difference. Okay. Now, if suppose if XC is equal to XC is greater than XL, then what will happen? Who is leading? Phi is positive and phi is positive, and current leads voltage. Current leads voltage, and it is a capacitive circuit. It is a capacitive circuit. Similarly, if XC is less than XL, phi is negative and I lags voltage, and it is inductive circuit. Circuit is known as inductive circuit. Okay, remember this one. They are asking this question here. All these are 1 marker questions. All those are 1 marker questions. Is that clear, all of you?
Yes sir.
Okay, done. An analytical solution is not there for our syllabus, so forget about it. And where we are using this resonance concept in tuning the radio or TV. Okay, in tuning the radio and TV. So tomorrow I'll explain sharpness and then sharpness and Q factor, quality factor, and the remaining is a transformer and AC generator. All these things I have to explain tomorrow. Tomorrow what time you will join? 5:30, right? Clear? 5:30. Okay then.
Yes, sir.
All is good.